All right, 2015 Calculus BC test for response number 2, part A. So we have this particle, and for all non-negative times, it moves along a curve in this sort of xy plane with a velocity vector. So we're doing a little bit of vector calculus. And we know that at time 1, the particle is at this point. Now, the the function for where it is at any time is going to be found like this. It's overkill for this problem, but it's worth sort of recalling. So we know that at any time x of t, y of t, not t, let me try it again, y of t, the particle will be at the integral from 1 to t of the velocity, and I need to use a different variable than t there, so I'll call it the velocity of, let's say, r, sure, with respect to r, plus the starting point, so plus x of 1, y of 1. How do we know x of 1, y of 1 is 3, 5? So let me change colors here. So we know that this here is 3, 5. We know this here, we're trying to figure out what happens at time 2. So x of 2, y of 2 is going to be the integral from 1 to 2 of v of some variable r dr. Okay, and I'm only really looking at the x part of here, so really I can break that off. I'll change colors again and say, okay, let's say, what happens to x? X of 2 is going to equal the integral from 1 to 2 of just the x part of this, cosine of r squared with respect to r, plus the x value here, 3. So basically, we're going to get to 2 by starting at what happens at time 1 and integrating the rate all the way up to 2. Hop over to the calculator, type that in. So math 9. The function, I'm going to type in cosine of x squared with respect to x from 1 to 2. And that's the most common mistake I see my students make is they stop there. Don't forget you have to integrate the rate and add on some sort of starting point, or in this case the point at time 1. And we get that the x coordinate will be approximately 2.557.